In this video, we're going to discuss the concept of gravitational forces on a planetary level. What are we going to do? We're going to review the ideas that led up to the concept of gravity. We're going to look at the laws of planetary motion. We're also going to look at Newton's law of gravity and apply that law of gravity to the laws of planetary motion. We're going to see how we found the mass of the sun as well as the other planets. We're also going to see why we learned the mass of the sun and the planets before we actually knew that of the moons themselves. We're going to define the term field force, define the term gravitational field, and see how the density of a planet affects the gravitational field that that planet creates. Why are we doing this? Because gravity is one of those key forces of the universe. Its property governs the motion of all falling objects, as well as that of all the celestial objects. That includes stars, moons, planets, comets, black holes, and so on. Also, while you might think gravity is a very simple concept, it is one concept that many people struggle with, especially when dealing with gravity on a planetary level. So it takes time to develop an understanding and to become comfortable with the material and especially the mathematics that we'll have to work with. Now, near the beginning of the year, we had looked at the early models of the universe, starting with that of Aristotle, who came up with the first documented model, where we have the Earth as the center of the universe. There are four basic realms that cover the planet, where the four basic elements of earth, water, air, and fire belong, each one in their respective realm, and then the rest of the universe orbiting the Earth, made of some other element other than those that we find on Earth. He had come up with the concept of natural and violent motion, where if an element is to return to its realm, for example, if you take a rock, hold it up in the air and let go of it, and it falls, that would be natural motion, because rocks don't belong in the air realm, they belong on the earth realm. And violent motion, where if you force an element out of its realm, simply by throwing a rock up into the air. When you throw the rock up into the air, you give it a value of motion known as impetus, and once that impetus has run out, the rock stops and then moves naturally, going back to where it belongs. However, once it gets back to its own realm, it stops moving because there's no reason to move anymore. The universe, not being any one of the elements, does not follow the laws of natural or violent motion. They follow some other completely different set of laws. We don't know what those laws really are, other than that they seem to always be moving in a circle and they never stop moving. This is unnatural to compare to anything that we see on Earth, so he believed the universe was made of some other element, some fifth element called ether, and we'll never understand the universe because it doesn't follow our rules and we're not even made of the same material. Now, Aristotle's model became accepted science for many centuries, and later on, there was Galileo who revolutionized the thought on objects that fall. This was first done with his interest in how pendulums swing back and forth and noticing that heavier masses do not swing any faster than lighter masses, which is a contradiction to what Aristotle suggested should have happened. He also investigated then balls rolling down ramps and noticed that objects that fall actually accelerate, speeding up, and the distance that they travel follows something known as the rule of odd numbers. These were in direct contradiction to what was suggested by Aristotle's work. Further investigations also led him to come up with experiments that would lead to concepts such as the conservation of energy and inertia. These were developed by other people later on, but they were based upon Galileo's earlier work. Galileo also invented a telescope, which he was able to then use to make observations about the celestial objects that he, of course, could not reach because they were in space. And from his observations, noted that the planets often have moons themselves, much like the Earth, and from his measurements was able to come up with a model of the universe where the sun is the center, not the Earth, and the planets all move around the sun. In fact, the Earth isn't even next to the sun, it's third in line from the Earth. a concept that was revolutionary and met with a whole lot of resistance because it was a threat to how we view the universe and the social order that we had at the time. Now, Galileo was able to make observations about the universe and come up with a model that was fairly accurate, not completely, but more accurate than anything that was based off of Aristotle's work. But he was not able to come up with an authentic reason on why the universe moves the way that he does. He had some theories that were out there, and people had other theories that were trying to support this or describe the motion. Some theories included that perhaps there are crystal gears. The universe seems to work like some sort of clockwork mechanism. Perhaps there are gears that are making everything move, and the gears are invisible. They're made of crystal or something, and so we just don't see those gears. And they were able to come up with models, kind of like we see here, to illustrate where the planets do move with a fair amount of accuracy, but the models were never 100% accurate and had a lot of limitations. Other theories that were out there was perhaps there is, in fact, still divine intervention that's taking place. The hand of the deity that you worship, or angels or other servants of that deity are moving the planets and things around, and so that is why we see the motion that we see. At no point did Galileo try to come up with a official scientific explanation, because there was no way for him to collect any evidence or data to support something like that.